Okay, now it's clear.
Yeah, perfectly. No, it's clear.
Okay, so what I was talking about. So I was talking about like we are going to deploy the application in the Kubernetes and the infrastructure setup thing will be done by the Terraform. So the Terraform is basically developing the entire infrastructure on the cloud AWS. Okay. So we have this application in the GitHub and we can see that how the Terraform is deploying this entire application service deployment in Kubernetes. Okay. So first we look at the individual tools. Okay, so I found some documentation. So I explain first about all these individual tools. Okay, so let's start first the Terraform, right? Let's understand because these are the prerequisite things. So Terraform, EKS, Docker, Helm chart. Okay, for infrastructure related, these are the tools we need, and we need to understand all these one by one. Understand, and then we will see that how practically we'll implement it. Okay. So when we talk about the Terraform, so we know all that Terraform is an infrastructure as a code. Okay. So Terraform has its own life cycle, right? Terraform has the different stages are there, right? Starting from the Terraform initialization, Terraform init, plan, okay, apply and destroy. Okay. So when we come to the Terraform, so Terraform is a first of all is a cloud agnostic, right? It's not depend on one cloud. It's doing the provisioning for any cloud. So first of all, we need a provider because provider is the which cloud you want to do the infrastructure provisioning. So Terraform is creating an infrastructure for you and it is automating, right? Because you don't need to create a single instance or multiple instance manually, right? You are doing everything through the through Terraform script. So you have to write some script code. So once you write a script and you are applying this script on the cloud and it is accessing your security credentials and it is whatever like Terraform script you are providing the resources, right? So next thing comes in the Terraform resources. So first you provide the provider. The second thing you provide the resource, right? Which resource you want to access of your cloud. You are saying, okay, I want to access S3 bucket. I want to access EKS. I want to access Lambda, API gateway. So you have to provide individual resource and you have to configure that particular resource. Okay. So when we go further deep dive in the Terraform, so we see here the Terraform has the different stages, right? And each stages is properly configured and we are going one by one to the next stage. Okay. So that is the basically the life cycle. And we come to the Terraform core concept. We need to understand, we need to define the variables. So there are two types of variables like input and output. Input variables you are giving, right? The input data, right? You are telling about what is your S3 bucket, what is your security credentials, right? Those things you are providing as a TF variable, input variable, okay? And output, right? You are creating some results, right? From your infrastructure, right? So that you are creating the output variable. Provider, I told you, you have to choose any one of the cloud and AWS is providing a lot of cloud, Terraform is providing a lot of cloud providers. So you can choose any one of the provider for which provider you want to create a resource. Module is there. Module is just making it like a directory, right? Whenever we want to say, okay, our root directory is there. And from the root, you are creating a separate module. So here, what I can do, EKS, I can make it a one module. I can say, okay, Lambda is another module. Like I can separate out my module. So suppose in future, suppose I say, I don't want to use Lambda. I want to just use EKS and I want to use some other module. So I can pick it up those modules. So my module file will not be depend like entire code write in a one file, better to separate into the module. So that's the purpose of the module, right? So module is giving you basically the modularity. Okay. And state file. So Terraform state file. So you are defining the state variables, you are defining resources, you are defining, and you are defining all these configuration things. So how Terraform is working? Terraform is basically you are using some OS, right, where you are having a Terraform installed, and Terraform is basically invoking your resources, right? It is like a life cycle. It is do step by step. Okay. So you can go through it more deep dive, like how the Terraform works. Like these are all the artifacts of the Terraform. right? State file, TF variables, provider, instances, right? So these all TF files will be called from main TF. So main TF file is a file. From there, your invocation will start. Like we know, right? Java or any other programming language, we start our program with the main. Okay. The same thing is in the Terraform. Terraform is also using its own programming language, HashiCorp, right? SCL. Okay. So this programming language, you can even do the programming code you can write. Even you can write a conditions, you can write loops, right? Like you want to create a number of like instances, right? So you can, all things you can control from the Terraform, this HashiCorp language. Okay. So you, if more customization you want to do, you have to write a programming code. Okay. So this all things are there. Okay. Now next thing is, this is the basic things about the Terraform. Now we come to the EKS. So EKS, we know it's a managed service of AWS, right? Managed service means like AWS is managing the service. Infrastructure part of this service, right? EKS, you don't need to manage, you're on. Okay. So one other way we can create a Kubernetes, we can use kubeadm or we can use minikube. These are our own managed one. But when you are taking up the AWS EKS, it's a Kubernetes managed by AWS. Okay. So it is obviously paid, okay, because you will be charged for that. Okay. As you pay go model. Okay. So when we are using EKS, so first the advantage is like resources things, the load balancing, everything is managed by the AWS. So that infrastructure in the behind, you don't need to manage your manually. So here is a control plane. Those are the basic same concept in Kubernetes, and same concept is a EKS. EKS is just managed service, but behind the scene, everything is managed as a Kubernetes. Okay. So the concept in the Kubernetes is the master node, API server, etcd for the as a key value pair data store, which is storing your configuration details as a key value pair. API server is there. It controls the API server, right? Which is a kubectl, like it's a kubectl, like you can as a control, as a client tool, you can write a command. Control manager, scheduler, right? So these are all artifacts of the typical Kubernetes ones. The same are inherited in the EKS. Okay. So pod is a basic fundamental unit, right? Which is your application running at a time. That is your pod. Okay. One container can have many pod or one pod. Okay. And these pod is nothing but your application running at a one point of time. That is called your pod. So pod is having the networking, storage, IP address, all these things in the pod is there. Okay. The same pod, you call it container in the, like you can high level, you call in Docker, right? The Docker, we say container. Okay. So pod is the basic fundamental unit of the Kubernetes. Okay. Is it clear so far, right? Like this is like you have to go deep dive in the Kubernetes, then you will get more idea and more concept. Okay. So how Kubernetes works and what is the terminologies the Kubernetes is following. Okay. How the Kubernetes invoke, right? So this all. So Kubernetes cluster, you can install by different way. You can do manually. You can do the user interfaces there. Okay, you can go to the AWS instance there. You can install manually. Okay, or you can do the command line. AWS EKS command is there. Okay, CLI. So through CLI you can install. Okay, so there are multiple ways are there. This is the UI way. So you can create a Kubernetes cluster. But here we are going to create a Kubernetes cluster in EKS through Terraform. Okay, so we have written all the Terraform scripts, and these Terraform scripts will run it. Everything will be run automatically in the AWS account, and we will get a EKS cluster. Okay, so this is all manually we are doing. This is all we are doing manually. Okay, and these are the access key, secret key. So when we are connecting to the our local machine to the AWS, so we need a AWS CLI. And AWS CLI, we have to create a user. I will show in the application. And we have to create a user, and we have to create a access key and secret key for that user. Okay. And node group is the part of EKS, because once we create a EKS cluster, it's an empty cluster, but there is no node group. So we have to create a one node group inside the cluster. Okay. So we have to create a node group. And this IAM policies, right? Because when we are going to access EKS cluster, we have to define some policies, and these policies are the roles, right? We have to create role and policies, permissions we have to create in the So one role I will create with this name, and I will add these 3 policies in that role. Okay, so that whenever I'm just creating this role and adding these 3 policy, so this role can be used by our EKS. Okay, so that is particular to EKS cluster to use this role, and this role is associated with these 3 policies. Okay, so this is the manual way. I'm just going to show you, right? You can compare your like how you are going to create with the Terraform and how you create manually this EKS cluster, and then you can verify by using the kubectl get nodes, and then you will be able to see your nodes are running. Okay, and then you can deploy any application, and this is a command line way. The second way which I was telling, this is the command line. So this is a CLI. You can create a Kubernetes cluster, and it will create a master and worker node. Okay, and this is all manual step you are doing. Okay, so this is about the EKS. Okay, and now what is a Helm chart? Okay, so Helm chart is like extension part of the Kubernetes. Like I can say, like I'm creating in Kubernetes manifest file, YML file, and these YML files, suppose I don't want to create these manifest file manually, okay, and deploy manually. So Helm chart is providing a package manager, repository package manager. So we can deploy our services, right? Just some official repository we can pull, and then we can deploy it in our local cluster. Okay. So Helm chart is having a 2 files, values and chart YML file. Okay. So we can configure our customized Helm chart, or we can directly pull the official images like Kafka, Airflow, different images we can pull up. Okay. So you can add the values in your values.yml and chart.yml, and then you can do that. Okay. So when we are doing in our local system, so Docker and Helm chart should be in our local machine. Okay. And the EKS we will be having in AWS. Okay. And Terraform also should be in our local machine, so that everything we will be doing from our local machine to set up in EKS. Okay. And we will be using that. Okay. Next, I'm going to tell about the application, the what application we are going to demonstrate. So this application is a Java application, and there are the 2 microservices are there. One is a book API and one is a client API. Okay. And these 2 APIs, these 2 load balancer is through the ingress, like Nginx. Nginx is a load balancer. So that is balancing the load, right? If one microservice is down, so another microservice will be available. So we know about all microservice architecture, because microservice architecture has its own database, and it's independent to other microservice. So if one microservice is down, so the microservice will not impact to the other microservice, because we can easily debug our microservice, and we can debug, and we can troubleshoot the microservice easily. Okay, and this whole architecture is like provisioning we are doing through the Terraform. Okay. So when we are going to start it, so in this project, first setup is the Terraform setup for the EKS. Okay. So these are the all Terraform files are there. I already talked about, right? There are the different Terraform TF scripts file are there. So we are creating a BPC. BPC is a virtual private cloud in AWS. We have subnet and route table, NAT gateways. So it will create everything from the scratch. So just we have to provide our configuration in these TF files. IAM role is there, EKS node group is there, EKS cluster configuration is there. So this will set up the EKS in AWS. Okay. So once we are going to create a user. So this you can see we are creating our own user. We are assigning the permission policies to this user and creating a security credentials. So we are creating a security credentials and creating a key pair. Like I want to connect from my local machine, and then I will do AWS configure. AWS configure, I will connect to my AWS, my machine, I will connect with my secret access and security key. And then I will start my Terraform init, upgrade and Terraform validate, like it will validate my scripts. Okay. If any syntax issue is there, it will give the error, Terraform validate. Okay. Next is the Terraform plan. Okay, so these are all step by step. The Terraform stages are there, and we are following it. Okay, and then Terraform apply main TF. right? So this is your entry point from where your execution will start, okay? And once it's done, it takes a 10-minute time. And once it's all done, then we have to update the configuration of our EKS cluster. So whatever EKS cluster is created, you have to rename the EKS cluster. So we can rename the EKS cluster with our name, okay? We can do, and then we can check the get nodes. So this is the first step to set up just EKS, okay, in AWS. And the next step is our application, our Java application. So Java application has, these are the source code of application. So book application is there, one is a client application is there, and one is a gateway. So gateway is the entry point for these two microservices, right? For gateway only we can access the book and client, okay? We can access. So these are the, we are creating first Docker login, like we want to push the images in our Docker hub. Okay, so we have to do our own Docker login, and we will build the Docker image. And once we have the Docker image locally, then we can push into our Docker login. Okay, so three images we are building. One image for the Docker books, one is a books client, and another one is a gateway. So three applications we have, and we are building the three application images. Okay, once this done, locally we have built up the images. Okay. Yeah. Okay. So here then deploy microservice. Next step comes deploying the microservices. Okay. So that part will be right. We will be deployment YMLs are there. So there are the separate YMLs for creating a deployments. Okay. So we have a deployment YML is there. Persistent volume claim YML is there. So for every application, microservice application, we have one PVC YML, and one is the data deployment YML. So we will be applying these YMLs, like there is a apply command is there. Okay, so we will apply this apply command, we will apply these YMLs. But before we this CSF, EFS, CSI, this is the Elastic File System CSI driver. So we will be using the Helm chart for this. Okay, so this is all YMS. We are creating YMS, and then we are deploying the YMS, and then we can see our Kubernetes. We can see the pod. So after deploying, we can see all the pods are running. So there is a book API pod is there, service is there, and book and this client and gateway. Okay. Okay. Kamal, I'm making you presenter. Okay. Yeah. Are you able to hear me, Kamal?
Yes.
Okay.
The
Yeah, you
software
can
is
show
still
your screen.
uh, can you see my screen?
Mm, Maybe still not. Yeah, we are able to see.
Yes, so it is still destroying my previous cluster, so not to share.
Okay, Abhi still is destroying. Okay.
Yes, the cluster is deleted. It's just the security group and the
Uh,
VPC subnet is still on the
yeah,
process.
it's taking a time to destroy the entire cluster, right? Okay.
Yes.
Could you check it again? Everything is in AWS cleanup, right? I think we can start parallelly another terminal, okay, because this is the destroying, right? So that is not impacting, right? Just
Okay. Yep.
yeah, we can start it because
Okay.
I think how long it is doing? 14
Uh,
minutes. 14 minutes.
yeah, 15 minutes now.
15
Yes.
minutes now. Okay.
Shall I start on the another
Yeah,
terminal?
another one we can do. Yeah.
Okay, so
So this is all the application side. Okay. So first we are going to Terraform, right? We are just Terraform scripts we are running. Okay.
yes. So if I
These
go,
are, mm,
so these are my Terraform script to create the EKS and then
mm,
thing. So if I do Terraform, if I run this command, This will validate because I need to create the IAM user, everything.
But IAM
So
user already you have, just show that IAM user, and you have created already the access key, secret key, right?
yes,
Already you have, right?
yep,
So you can use the same user. I have already told about that. Okay.
yes, yep.
What is this state lock is saying?
Because this process is still running, so I
Okay.
think it's not able to.
Okay, let's show that this user first. Okay. Okay. Meanwhile, this is deleting. So go to the AWS console and show user and add the permissions. Okay. How to create our own user for this Terraform.
Okay.
So I am user and
So this is the user I create. This is the user, and
Hmm.
then on this user we have all the access, and we give
Administrator access.
administrator access, and it's allowing the administrator access on all the resources, and action is whatever action like get, put, everything is there.
And security credentials need to create a access key, secret key, right?
Yes.
So you already created access key, secret key, but someone wants to create, so he has to click on this create access key. Can you click on this? Just we show them. Okay, and there is an option, command line interface, or this fifth one.
Command line
Application
interface.
command line interface. So command line interface, we go and we go next. And so it will after this step, this will create an access key and secret key. Okay, and this access key, secret key we have to use when we are doing the AWS configure. Okay, so there is a command AWS configure. So
Yes.
but it will change your access key, secret key, new one, right? So you
Yeah,
don't.
so it is already been, if I go to this directory, I think cd. So it will be stored here on this
It's
type.
stored here. So
Yes.
can you do the AWS configure? It will be coming previous one.
Yes.
Configure. So it is already coming the previous one. Enter, press enter. So if someone has created new one, he has to give the new one. Okay. Okay. And default reason and next. And the output format anything, or otherwise you don't need to give anything. Okay. Next. So this is now you can you show AWS S3LS so that we can see the buckets S3LS. So once you do the AWS configure, you can see this is the one bucket is there. So AWS S3LS we can do. So we can make sure, right, we are able to connect our AWS account. Okay. So any service we can connect through AWS configure. First, we have to configure AWS configure in our local. Okay. Can you check that is deleted still? Okay, it's taking delete. Okay, so that is the first step. We have to create a user, give the administrator right, and next thing is we have to create a security credential. Okay, and then we have to do AWS configure in our local to connect to the AWS account.
Yes.
Okay, so are we still not deleted?
I think it's still not deleted. 20 minutes. It's still deleting, so it's still in the process. Maybe I do manually.
Manually EKS cluster, but
PPC.
I think you have to go to the other dependency, right? NAT gateways or subnets, those all. I think better to let it do, because it will be conflict, right? Because if you, it will take maybe 1-2 minutes more. So I think it's completed or not? It's completed, right?
Yes, cannot be deleted. Node has definition, can be deleted.
Something is not deleted. It's saying deleted file system EFS cannot be deleted because it has mount target. Something is a dependency. Here is saying internet gateways and this subnet and 3 things are not deleted. Can you try again?
So 3 things are easy to
One is
find.
the EFS Elastic File System, and EC2 subnet is not deleting, and internet gateways. Okay, this is all destroyed. Okay, subnet is destroying, EFS is destroying, or net gateways. Okay, these 3 is destroying now. Okay.
What to destroy?
I think it is keep trying, but it is not able to destroy.
Yes.
EFS. Okay, let's do manually go there. EFS and internet gateway we do manually.
Okay.
Go to Elastic File System. Yeah, yeah. Nothing is there.
I think it destroyed it.
Okay. And
Internet.
check the internet gateways. Okay. I think it's dependency there, right? Internet.
Yes.
First you go internet gateways to delete.
Okay.
Delete this one. Detach from PPG, yeah. Okay, detaching unsuccessful. No, it is public address before detaching. Okay, check this one. It is not able to delete. It is trying. Or we can give the new one the name, right, in the configuration. So it will.
Yes. Yep.
Just we change it, right? So it will create a different. So subnet internet gateway. So I think main one you do. Just tag main one, so this will create a different one. And anywhere like you have to change this main. Can you search main
No,
everywhere?
it is only just the tag name, so I don't think we need to change it.
No, it will create a new tag name, right? It will create new tag name, and then it will use it everywhere with tag name main one.
Yes.
So I think only main one this BPC, so it will handle all the route and okay, we
Yes.
do it. You can stop this one. Okay. Your all the files are saved. Just check it.
Yes. Auto save is enabled.
Okay. Okay.
The Terraform file. Did the Terraform upgrade it? So we have to initialize and then validate. So Terraform validation, and it will give us. Maybe I think I will delete this.
Previous one. Yeah. Okay.
Yes. So we'll have a new one.
Again, error is giving. State lock. Terraform acquires a state lock to protect the state from being written. Something lock false flag, but this is recommended.
For this demo, let's try this.
Okay. Okay, this is done.
We apply from this main.
The new main.tf plan is created. So
Yes.
again, here is also apply giving error, lock false. It's saying you cannot use many parameters. Disable locking. Too many command line parameter.
Oh, okay.
No, this is coming because of the previous one. The Terraform acquires a lock. What is this command? Terraform acquires.
Terraform plan, can you check? If it's
Terraform acquires a state lock. So this.
remove, can we do that?
So you are getting the error in the Terraform apply command, right?
Yes, because
We need to unlock.
How
Force
to
unlock.
unlock?
I have shared a command. We have to put the lock ID with that
Can you
along with
check
that
the
command.
command?
Terraform force unlock and then the lock ID.
Okay. So how to get the lock ID? Oh, lock ID.
Yeah, it is there. Yeah, just the path.
Yeah. Change the
Login.
lock ID to remove this lock ID. This lock ID will come actual lock ID, right?
Yeah.
Okay. Where is the lock ID?
Lock ID is in this,
Yeah,
I
this
think,
one.
Terraform
Oh
plan.
yeah,
page.
lock info.
Yeah,
Lock
just below
info.
the error.
Kamal,
Yeah,
yeah.
ID.
Before the path, right? The lock ID is there. ID,
Oh.
right? That is a lock
Yes.
ID.
Where
7
is
6. No, 7 app. This one. This number.
Just below the error. Yeah, this one.
This one. Okay. Cannot be unlocked by the another process. So
not sure.
this error locking.
Is this locking is done by DynamoDB?
No, not DynamoDB. Here is not DynamoDB. Actually, it is.
DynamoDB table, I think lock
Like
has
which?
been done
Yeah. First of all, we should know like which kind of state lock we are using for this.
Okay, so internally it is storing in the information in DynamoDB. There is no
There
table.
must be a table in that.
No, there is no table
Yeah,
there.
we haven't configured the table. I think it is
Mhm.
from the AWS internal.
No, somewhere we are just defining the state lock, like how it would be locked and all. So that we need to check.
There must be a code written here only.
Can I find here?
What is this TF state backup? Maybe this file we need to delete. What is this file?
Okay, let me delete
That-
every.
Where this state file is saved in S3 bucket, right?
Yeah. So I think that is giving issue.
So there must be a log on it
Hmm.
using DynamoDB table.
Can I find it here? No.
Okay, can you go S3? There we can check it. Any file?
No, there's no file. I think this file was already
In
there.
Terraform unlock command, na, can you give force? That once it.
We tried that, right? Terraform force unlock. Can you do again command?
Force unlock, lock ID, and again force. We are pinging a command. Sorry.
This command you run Terraform force unlock. And meanwhile, first you run delete this backup file, because backup file is created by them. No, not this one. This next backup, no backup.
I think I can delete all these files as well, like log file. Here is the
Yeah,
log.
that is the reason, because we have to create a fresh one. So this lock, this lock, all log files you delete. Yeah, this lock. Okay, any other one?
Maybe this one. And
No,
then
no,
the
not
plant. I'll delete the plant and then
plan.
Okay.
Okay, now you try. Again, error here, lock. State lock is coming. Forcefully lock we can try. What is saying? Resource is unavailable. And tf state lock.info, no such file directory. I think we should do the force unlock command. And there is a change. Can you check the ID?
How do I check the ID of this one? Give me a second.
What is this created log?
This
Delete
is-
this one. This is
This will file will create when we initiate the Terraform init. Yeah. You run this command, force command. Yeah. Force.
Yeah, it's not-
but it need a lock ID.
I think I'll delete all the files that Terraform created and then rerun it again. I think it will resolve
The
it.
last time you ran, right, Kamal?
Yes,
So this issue didn't come. This.
the lock. This
Kamal,
one.
are we using a state backend or not?
Oh no. These are the original files.
Okay.
So only these were the files. Let me now do this. Hopefully it will work. I deleted all the files that Terraform integrated.
Okay. This is created just now, na? Look, I said.
Yes.
Okay, ma'am.
Now
Bye,
validate
ma'am.
is
Bye, ma'am.
It is your syntax problem, right? Can you check it? Right, somewhere line number 148, like some JSON path in this IAM role TF you go. And there is a 148 line number. So this JSON have you deleted? Because this JSON
Yes.
is needed. Yeah, it needs that JSON.
Okay.
From where you got this JSON? In the same source code, right?
Yes. I'll copy that. I'll get that
Mhm.
JSON again.
Because it is not able to find the JSON.
Terraform.
And it should be in the same path you copy. Okay.
Can you check your task manager once? Like if there are any local processes there for locking the state, like if we are not defining the state lock, then it would be a local process. Then we need to kill it manually from there.
Local process. Okay, let's do this one from the scratch. If this error comes, so we'll do that.
Yeah, sure.
Because we deleted all. So
Oh. Do I do the
validate, you're doing last validate command.
yes?
Okay, now validated. Okay, creating a new TF plan.
Okay, seems like it is working now. 43 to add, 0 to send, 0 to destroy.
So
Okay.
last time you got the plan also the lock issue, right? So now it's not coming. Now it's
Yes.
created.
Yeah,
It's fine.
now it's creating.
Okay. So local process where we can see the local process like some PS command.
Yeah, exactly. We have to check for Linux machine, we need to check for PS command, and for Windows, we need to check in the task manager. Yeah.
So local process for what we have to kill?
This Terraform is state locking only. Like we have
Okay,
installed
okay.
this Terraform on our local system only.
Oh, okay, okay. So
Yeah.
we can grep and then we can find
Yes,
if
yes.
any
Then we
already
need to kill it by
kill.
kill -9, something like that.
9 kill minus
Yeah.
9.
Yeah.
Okay, so existing
If we are
section.
defining, if we are defining any remote backend like
Mhm.
S3 or DynamoDB anywhere, this Terraform cloud as well. So we need to just kill that by that command only. This kill ID and all. Yeah.
Okay. But better to delete all these log files, right? What are these log files? So this issue was coming all log files. If we delete, so then it can also resolve. Because whenever it start new one, it creates its new log file, right? Okay.
Yeah.
So previous log file it will not allow, right? So that is the reason.
Yes,
Okay.
yes.
New subnet PPC.
Two subnets on BBC is now created.
Can you check where is the main one is coming? That we have given tag, right? BPC tag we given. Somewhere we gave in the.
Yes, BPC.
So,
Oh, two BPC with the same name.
okay, download this. This is the old one, right?
Yes, it's not coming here for some reason. I think we just change the tag name for
That's
internet.
I'm saying. Where is the main? I think it's overridden. How it
Yeah,
happened?
it overrode, I think, because we changed on the internet gateway.
Yeah, main one. Okay. So it's not a problem. We can have a two main existing one.
It will kind of map which one it created, maybe, because there's only the tag name is same, but the ID are different.
BPC ID is different.
And same here. This is the latest one.
So node group is created in the EKS cluster. Okay. Inside the cluster you go. Resources. Okay. And the compute part, compute, I think there we get. So here the node group will come up. It's still not created.
Yes. It will take time. Only 3 minutes.
So 10 minutes is the approximate time, right? 10 to 12 minutes.
Yes.
Okay, we check this YMLs, right? What are the YMLs? So we explain this YML. So go to book data. So what are the, okay, the application is, first we look at application src main.py, you open book main.py.
Oh, which one? Sorry.
Okay, let me take control. Okay. So here is two applications, like one is a book application. So which has, this is a book data, ID, title, author. Okay, so this is the book data and this is the main.py of this book. So this application, what is doing, it is reading the data file from the pod. Okay, and this is the REST API, fast API. Okay, and it is a book class. Okay, and this is the like a REST API call. So /book is a REST call, and what is doing here? It is just getting the get book data. So based on your file, right? Your it is this get book data function. If we go get book data, this is, so it is reading the file and it is taking the ID, and this is creating a list of record. This is the list data, and it is creating a list of all books data, and it is returning back. So this books API, and one is a book/book ID. So suppose it's specific book ID I want to get. So it will search in my list of book, find book. It will be, so these are the REST calls. So we define a separate function. Find book is a separate function is there, find book. So if I particular book I want to find in my list of books, so I'm just iterating the list of books and I'm getting the ID, I'm matching, and I'm returning that book. So this book is related to two APIs are there, like book/book ID, and one is a /books, all books I want. Okay. And another application is a client application. So client application is also having the client CSV file, and client CSV file is having ID, name, and type. So three types are there. Okay. ID and three columns are there. Okay. And the source code of this is main.py. It has the client APIs are there. The client APIs is the client/client, all the client I want to get, or a specific client ID I want to get, /client ID. Okay, so both are the having a method get client data. So here I'm reading the file and getting the client ID, and I'm reading the find to specific client ID. So this is the APIs code is there. So these are the two source codes. This is not a Java application, this is the Python application. Okay. And another one is a gateway application. So gateway application is also having the source main.py, and this one has these APIs called. So this one is also again Python code, and it is using the fast API, REST API, and book class and client. So both are integrated here in a one place in the gateway. So gateway is the entry point for both APIs, right? Book and client. And here /clients, so it will redirect to the client. So here it will redirect to client, and it is a asynchronous call. And the books, it will redirect to the book. So whenever I want to connect to the books, and it will connect to book, and I want to get the client, it will connect to the client. Okay, so this is the gateway. Okay, so this is gateway, and this is the Docker file for each three one. So Docker file is, you can see here, so Python we are getting first, and working directory I'm setting app, and copying my source code, my main.py, I'm copying in the app.py app. And then I want to install my whatever requirement.txt, I will install it. So what I want, FastAPI, and this is some Python library and UVcon something. So this all I'm installing it through my Docker. And then finally exposing the port, and then I'm running my Python application by this cmd command. So I'm hosting on this my local host. So same like Docker file is for client also there, same Docker file for same client Docker file for the gateway. Okay, so we need to create these three applications, right? So where are the command? Okay, this one. So here, if you see the commands, so these are the three applications. So as many as microservice application can be there. Here are the three applications are there. So we are building the three images. If you have 10 microservices, like some shopping cart application is there, like there is a cart application, there is a catalog application, order application. So all microservices will be separate. source code, right? And we are creating an image. So Docker build command, and we are creating an image, and then we are pushing an image into our Docker Hub. So Docker Hub is the repository where we are pushing image, and anyone can pull this image and then build the application locally. Okay. So here using the FastAPI, we are building the application, and the Docker, we are creating an image. Okay. And then we are deploying application using the Kubernetes. So Kubernetes files are, these are the YML files. So if you look at here, so every application has, like, one is a data. This is the persistent volume file. Okay, like we want to create a persistent volume claim, like storage data, right? For that, and EFS file system is a storage class. So this one we are already configured in our Terraform, right? And same for the deployment file is there. So for book, there are the two. Okay, okay, what is the mount error? So this one is, I think some ID you have to change it. Kamal, I think you have to copy your in the AWS and then change it here. I think because it is not able to find the existing one. So some new ID is created in the file system, EFS. And that ID you have to change it in the code. Yeah, this ID. Yeah, because this ID is different, whatever it is looking. Can you search it, this one in the
Yes,
search?
so it should be on EFS.
In the which file it is searching in the, I think EFS.tf, any,
Here?
yeah. Yeah, here you two places. So this is different, right? What you copied.
Yes. So if I copy it and paste it.
So two places is giving error, right? Okay. Now you have to run it command again.
Oh, okay.
What is saying? So all steps you have to do, but it will not take that much time, right? What?
Yes. It will be
Only
quick.
EFS side it got the issue, right?
Yes.
So this thing we should remember, right? Whenever we have the file system ID, so this file system ID we have to change in our this EFS mount target TF.
Yeah. Then I can apply. Now it is creating.
But Kubernetes cluster is already created, right? So that will not do. Can you check in the node group now? Compute. Okay, node group is. Node group has come. Okay, I think it will do only that EFS step. It will do again.
Yes.
Because it's not completed.
Yes, yes.
So, but it should take the same time, or it should. Okay, only EFS is doing. Okay, so I think it will not take much time. So EFS one is still creating. Okay. So this deployment YML. So deployment YML, we have defined here our volume, which is our the data folder in our pod. Okay, so I have to copy the CSV file in our pod. Okay, so that step we will do kubectl cp command. Okay, and this is the image we are referring from our Docker Hub. Okay, and other things are like we are defining our persistent volume claim. So we are giving a reference of that. The same thing for the client data PVC and client's deployment YML. And the same thing is a gateway deployment YML. So for all three applications, we have a separate YML files are there. Right, this. Okay. I think here is needed also. You can change here because otherwise this will be giving issue.
Okay, yes, I will change it.
Because when we run the Kubernetes command, then it will give issue. Okay. Okay, so that is completed, right? So
Yes.
EKS.
So, you can check this with from the console.
The name of the cluster is RVM EKS. So we have updated the config. Okay, so we have updated the config file in the kubeconfig. Okay.
Yeah, and then now I think we can get the pod names to node.
Okay, so two nodes are coming and get pods you do, so there is nothing. Okay.
Yeah.
Node group to desired size. Okay. Okay. And just do get pods because we should not get any resource. kubectl get pods.
Yeah. None of it are created, so installing. Yeah.
And we are doing in the same namespace, right? We are not creating a namespace. So default namespace we are doing, right?
Yes.
So ham repo add, this is a ham repository command we are running, okay? For this Elastic File System CSI driver. So ham chart is like specifically only for this particular thing we are doing. Otherwise, we are not doing anything else.
Yes, just updating the Kubernetes cluster.
Okay, so already exists in the repository, so no need to, yeah, okay, ham upgrade. Okay, so get pod. So now we should get the pod of this EFS. Okay. The same command they given. So now we are able to get the controller pod and the node. Okay. Get pod. Okay. So it is. Can you refresh it again because it is container creating?
Get pod.
Same command you run get pod. Okay. Now it's 3x3 running. Okay.
Yeah. So we don't need to do this command. So now I think the next step is to deploy the actual microservice container with Docker. So for managing book
The
client.
Docker login is there.
Sorry, yes, Docker login. I already opened Docker.
So this all you delete. No, yeah, because we'll create again. So Docker should be installed locally.
Yes, so if I do Docker login now.
Login. Okay, login succeeded.
And then
Build images.
oh, I need to go to the correct
All the specific directory you have to go.
yes.
Because there is a Docker file is there. There we run this Docker build command.
And we are doing this for the book.
Okay, first we are doing book 1. Okay, and we will push the image. Even this step first already we done, we don't need to do it again because we like if we have already pushed the image. Okay, but if you are doing first time, so we can push the image in our Docker login. Okay, so here the one is coming. Okay, it is saying already exists in the this.
I'll do the same for the
So second application will go client application.
yes.
We build the Docker. Okay. So this is a third application gateway.
Yes. So
Hmm.
Okay, so once we done that, we can do this command kubectl git pods.
So we should get 3 more pod, right?
Yes,
So
now we are deploying the microservice using the Kubernetes. So I need to go to the Kubernetes directory,
YMLs are there.
and then we deploy each of this first create and then deploy the book service, and then also create the
So we are not doing client YML deployment. Oh, not client, gateway one, because 4 are there. Okay, gateway.
gateway we do at the end.
And okay. So this is
This
okay.
is for the client, and this is
So we can check persistent volume by get PVC,
these are our
and particular PVC I want to check. I can use command describe PVC book data or client data. To 2 PVCs are there, and they are using storage class EFSSC. Okay, are we still pending?
yes. Also, it is saying pending.
Deployment. Are we still 0/2?
Okay, maybe I do the storage EFS. Because this GP2 was the default one. Now we created the EFS, and then EFS is now being applied.
Hmm.
And then we have to copy the Git board.
This will show all the pods. So this
Yes.
is still creating, container creating. Can you refresh again? This book and client both should be there. Okay, error is there.
Should be running or creating stage something.
Again, one more time you do get pod.
Run with -w.
W. Okay.
Yeah.
Can you do with
That will
W?
show the live watch.
-w.
Yes, yes.
Hmm.
Run.
So now it's showing crash back loop. So
Now
what
it
the
will
issue?
show the
How can
current.
we check?
Check the log of that pod, which is coming in crash loop. Kubectl logs and pod name.
Yeah.
Put Control C.
Control C. kubectl logs, pod name. Any one pod we take it first.
CTL get log.
Yeah, put enter.
No, I think kubectl logs only.
Log.
Yes.
Kubectl logs and pod name.
kubectl.
Namespace should be there. -n namespace.
Namespace is the default. We don't need to give.
Okay.
kubectl. So this is the error is coming. Something US. So this UBCon is not.
So crash looped this. not too sure what is
No, crash check loop, this ubcom, what error is coming? This is installed or not installed? Okay. This guy.
Code name is, yeah.
So go down. Yeah, this is, but reason is down. There is a reason is given here, yeah, in the bottom. So what is saying here? Running pod has unbounded persistent volume claim and restarting failed container API. Already present on machine. Something is saying image.
yeah. So
We have not deleted image. The version successfully pulled the image, create container API, started container API, and container image already present, and back of restarting failed container API.
then can I continue because this one is saying already exist.
But still pod is not coming running, right? Can you do again? Pod is
Yeah, all of them failed now. All the ports.
or we delete and do again. kubectl delete pod.
You can check kubectl get PVC. Your PVC is bind or not with PV.
Okay. Can you write command kubectl?
Kubectl get PVC. PVC. Physical volume same. Yeah, PVC.
So here volume is attached.
Yes, we changed from the volume to this one, but yeah. Status bound. Shall I delete all the ports?
Okay, kubectl delete pod. Pod, yeah. We do
Same
again.
storage class you have written.
What?
YAML same storage class EFS-SC. Same
Yeah.
yeah.
No, what are you saying, Gaurav?
Yeah, same storage class you are using in YAML EFS-SC storage class is there.
Can you check? Yeah, it's same. We have not
Okay.
changed anything.
Okay.
Oh, it doesn't delete.
It's not deleting. There is
It should delete now.
server doesn't have resource. It is saying resource is not created. What is?
Can you show that YAML PVC
Okay, can
deployment?
you open YML? Kamal, open the YML here.
Deployment YAML of that, yeah. But the storage class name
EFSSC. And go to client data PVC. That is also EFSSC.
Storage class.
That configuration we haven't changed anything.
No.
Okay.
Okay.
Okay, your EFS ID na, can you check it the old one because it is I believe is still some place. You have the old one ID because
I can copy this and then
search it. Okay. So it is, what is the file system ID you check? This tag you search, file system ID, which other places it is there. Just search file, copy this and search how many places. So we check because it's a problem. It's only 2 places. Okay. And fs hyphen you search anywhere is fs hyphen. The old one we come to know, and hyphen also. Oh, that EFS. So I think old one is your
What was old one ID? With that
old
we
one
can
ID. That I think some place it is not changed, I believe, right? That is the reason.
Yes. So EFS policy, this one,
No, not here.
mount target.
So these are the two places you change. Okay. Other than
I think this were the two places that needed to be changed, no?
I remember one more place you did also. Three places, right? A storage class also there. So here we change. Okay, and these two are the mount target. Oh, it's same only, no? All these three are same. Okay, you deleted all pod? It's not deleting. It's saying the server doesn't have the resource type.
If I think
So what is command for forcefully delete? Right, pod.
-force that
Okay,
we have to
delete
apply.
pod.
Delete pod -force.
No, not pod. Delete pod. Pod name will come. Delete pod name.
but if we want to delete every pod,
And then -force. Space -force.
-force.
Minus. Okay. This is
It's
something a server doesn't
Or,
have this.
or in deployment YAML, you can change replica set to 0, replica 0, and then apply. Yeah, or it will automatically apply. kubectl edit deployment. No, kubectl edit deployment.
Hmm.
And that deployment name you already have. kubectl get deployment or
No,
yeah.
kubectl get deployment command.
which one?
No, you do first kubectl get deployment. First you do that, you will get the deployment name. kubectl get deployment. Get deployments. Get deployment. And then you do kubectl edit deployment and deployment name. Deployment book API. So what needed to do here?
Replica side we have to do 0. So if we do 0, no, that pod will that scale down.
So
Again,
this
yeah.
replica is 2 to 0.
Yeah.
This
Log
replica
command
is 2.
scale 0, -FN scale 0.
At 2, no, you put R will replace that to 0. Yeah. Okay.
Okay,
It's
only
fine.
this one
Right.
or
This one only. It's fine.
okay.
Now save it.
No. Yeah.
Okay, the same we have to do for other deployment. Client API. Okay, so here this specification.
Put R and 0. Okay. Escape. Okay. No issue.
Okay, so now.
Pod will gone.
Okay, now you delete the pod.
Pod will automatically delete it. Yeah.
Okay.
If
Okay,
you
now.
want pod again, then you can do again to replica set. Again, you can change or
Okay.
Okay, so
You change it again. Edit command to change. Same edit command.
okay.
Specification.
yeah.
What was the command?
Two. Just put 2. And same you do for other.
Replicas downside.
No, up. Okay. So it's still
Can you check log of client port? What the error why it's going? It's also in crash loop backup only. Same kubectl logs.
kubectl logs.
kubectl logs.
Logs, yeah, pod name. In Docker file is an issue. Docker file exec command is there in Docker.
No, exec command is not there.
Okay.
It's a copy. Docker file is just creating image only.
It is showing an error on this one, no?
So these are the three libraries, right? This is.
Hmm.
Or we directly pull the image only. We have, I think rather than creating local image, right? We can pull the image. We delete image. We don't run the Docker build command.
In Google, I have seen there is showing I forgot to put winbash in starting at the top of SH file.
Which
Winbash is
SS file? Which one?
in Docker file.
Uh-huh.
Winbash
Yeah.
is missing.
Oh, instead of this main app and then host,
Yeah, winbash.
where to give bin bash? In the CMD?
1 second, I'm putting the link here. Chat.
Okay. Oh, yeah. Can you open the link, Kamal?
1 second, I'm putting 1 second.
The entry point, CMD entry point, bin bash. Okay.
But
Oh,
that
in the command, right? But this is not a shell script.
this is the Docker file, no?
In
Okay.
the shell script they are saying, or here in the Docker file?
1 second, let me check.
This is they are saying format error.
At the top of the SH file.
Yes, so
In here only you can give the Docker file. If don't know it will work or not in Docker file. In starting, it will.
In the starting, you can put it bin
Yeah.
bash. The first line.
Yeah.
No. It would
I think
be
this is only for shell scripting.
I
the
think.
Docker file should start from on instruction only.
Yeah.
It's not a bash script.
yeah, so also it is just yes.
Yes.
Yeah, I think in just behind the CMD, we need to use that shell. We need to define that shell. Let me tell. Wait, let me check.
Correct. UVCon. No? That correct. Command. Yeah. There only in CMD.
What we need
Yeah.
to do here?
That winbash there we have to define double quotes winbash.
So before that or?
Yeah. Before that.
Okay.
So it will call shell.
No, only bin bash, right? Not exclamation.
Not starting. Yeah. Not starting.
Slash bin bash. Or only bin
No. Hash.
hash. Okay,
Column.
hash.
Yeah. That hash exclamation mark.
Exclamation mark. And space.
No, not space.
Okay. Okay.
Space after comma. Space after comma you can give. After comma space you can. After comma. Like yeah. Argument it is passing argument winbash before UVCon command.
So way to give the
No,
comma.
no, not this. Yeah. After bash, double quotes, comma, space. Comma after comma space, one space. No,
You mean like this?
no, not get this. Yeah, not read this. Remove this double quotes as well.
Okay, single empty comma. Okay, like this.
Yeah, empty space one. Was
Okay. Same. You can copy for others Docker files.
remove one comma here, no? Two comma there.
Okay.
Yeah.
Okay. Just copy this one.
Yeah, it's fine.
No, entire one you copy, na same, right? It's the same thing, na, for every Docker file. The Docker image is not creating properly. That's the problem, right? So the pod is not creating.
In pod is trying to running evcon command.
Okay. That is the execute error is coming.
Yeah.
Okay.
Yeah.
Now you try one first Docker build. Let's see.
I apply Docker. Okay.
No, we have to create an image now because Docker this Docker file, right? So we have to create an image first.
Yes.
And we will try first this pod only. One we try first. Let's see. For YML for this.
It was working yesterday, not working today. Not sure what happened.
CDC. Okay. You already deleted, right? All the one. This book.
What is, why is it saying dangling?
Okay, it's created, right? Books API, but unused in use. Okay, we create a YML. Let's see. You're deleting.
No, I'm not deleting. Yes. So we create YAML.
Now we try YMLs for all. Only first we try books one only. Okay. Yeah.
So I need to go back again. So I think cd get.
What is saying already exists. Books API. Port forwarding we have not done yet.
Yes.
But this error, what is saying? Pod is coming now properly. Can you do? Oops. I think error is showing. This is same error. This. So everything is not deleted properly before because we have not deleted deployment also, right? deployment and all PBC, everything?
No.
Yeah, so not because already this.
No issue. You can apply that deployment YAML. It will take the latest image. kubectl apply -f. Already exists. kubectl apply you can do rather than create.
Apply you do kubectl apply instead of create apply. Just change up. No, kubectl create to change apply.
Oh, okay. Sorry.
So what is saying? So one time we delete all the things. How can we delete all the resources in a one command?
kubectl delete deployment like that. Resource.
Yeah, we have to delete like this.
Don't know whether that will work or not. WinBash, I think.
Yes, I don't think binbash will work.
Work, like we need to just put there, remove hash and exclamation mark like shebang from there. Yeah, just yeah, /bin/bash would be there only.
Do you need to do for the gateway config? Oh, okay, not this one. Yep.
Okay, delete all the rest. It will delete file or what?
Yes, from the node, I think. Why is this so stuck? Deployment point. I think this I will investigate more and then not sure where it's going because yesterday I was able to deploy it and then not today. Something not working.
Okay, some like now we create a pod. Now we try this last.
Okay.
Works. Because now everything. Okay, so nothing is there. Okay, everything is deleted.
Okay, but we keep the cluster.
Cluster we keep it. Now we run same image thing. New Docker build command to create image.
Okay, shall I delete from here?
This one you delete, yeah. Why it is not deleting? It is giving some failed. I think is
How do I pause it? Pause, I need to pause. Still, it says in use.
so this in use. I think it's use is okay. Now other images. Where is using it?
The
Volume
book
check to volume thing or anything which is not there itself. The volume, anything is used? No. Oh, running is stop it, yeah. Now delete some saying use. Okay.
it's already there, but
Mm.
let me try to push it. Will say this already exists. And then
Yeah, Docker images are coming. Okay, then this one last. Okay, next.
driver, everything is running.
I think apply command. One second. This command will be apply, na, right? One command is a create -f. Okay, create. You have
Says pending.
Mm-hmm. See, it is saying EFS SC not found. So this storage class you have not created?
It will, because I haven't applied it. I need to apply
Okay.
here.
Yeah,
PV.
storage class when you do kubectl apply -f.
Okay, ready. And so if I do this now, oh no, this one, it should apply the EFS.
Now do get pods.
Yeah, successfully provisioned. It is saying error.
Describe the pod. Now what the error? Kubectl describe pod and pod. Say this is failed content already present in the machine. Restarting failed container API. Okay, we'll do one thing. We'll do next week. Okay, so this
Okay.
you check the error.
I'll also
Mm.
try to debug what is
Yeah.
causing. Maybe it will be good learning and here. Yeah.
Or take it fresh, check out of this code and then do, because maybe some files are changed or something. So that we'll come to know.
Okay. Yep.
Okay. Yeah. Okay. Thanks everyone for the attending. Thank you.
Thank you.